You are listening to The Vocal Technologist. Spoken tech for your ears.
So right now, the artificial intelligence industry is, they're basically trying to keep a massive secret from you.
Oh, absolutely. The economics are completely hidden.
Right. Because for every $100 you pay for your premium AI subscription, the company providing it might be spending like $1,000 behind the scenes just to keep their servers running. It's wild.
Yeah, the math just does not add up right now.
It really doesn't. And that's exactly why today our mission for this deep dive is to synthesize this massive stack of tech newsletters, leaked memos, and research updates from mid-June 2026. We're cutting through the noise to uncover the hidden reality of AI. We are looking at how it's shifting from those fast, helpful chatbots we all got used to into these autonomous, unfathomably expensive, and honestly, geopolitically critical agents.
It really is a profound transition. I mean, we're moving completely out of that consumer novelty phase. We're entering an era where the underlying economics and, frankly, the security implications, they are secretly causing absolute panic in boardrooms and government halls.
Yeah, panic is the right word.
But to truly understand where this is going and why it matters to you, the listener, we have to start at the foundational layer. We have to look at the sheer brute force speed that these models are achieving right now. Because that hardware level efficiency, that's the engine driving literally everything else.
And the numbers crossing my desk this week are just staggering. Like, I was looking at Xiaomi's newly announced model, the MiMo V2.5 Pro Ultra Speed. They are hitting an inference speed of 1,000 tokens per second on standard commodity hardware.
Which is just absurd.
Right. Just to put that into perspective, human reading speed is a bottleneck at way below that. This is roughly 15 times faster than a standard ChatGPT or Claude response from just a little while ago. But how is that physically possible without just melting the computer?
Well, they're achieving it by fundamentally rewiring how the mathematics inside the model operate. So, for instance, Xiaomi is using something called FP4 quantization on the model's expert layers.
Okay, stop right there. FP4 quantization, that sounds like something straight out of a sci-fi engine room. What does that actually mean?
Yeah, it's a dense term. Think of a neural network like a massive, incredibly complex recipe.
Okay.
Usually, the computer calculates the measurement of every single ingredient down to the 10th decimal place. It's super precise, but it takes a ton of time and memory to do that math. FP4 quantization is basically like a master chef deciding to just round up the measurements.
Like saying just use a pinch of this or a handful of that.
Exactly. It compresses the mathematical precision required. You lose a tiny fraction of exactness, but the cooking time speeds up drastically without ruining the final dish.
That makes a lot of sense. So they are actively trading hyper-precision for raw velocity.
Exactly. And they combine that with another technique called D-flash speculative decoding.
Oh, I've seen that mentioned.
Yeah. So historically, language models generated text one single word, or, well, token at a time. They guess the next word, then the next. Speculative decoding allows the model to propose an entire block of words all at once, check its own math instantly, and if it's right, it outputs the whole block simultaneously. The speed just goes through the roof.
I saw Google doing something very similar with a model called Diffusion Gemma. The research paper mentioned a 26 billion parameter model using text diffusion to generate text blocks simultaneously. And that's giving them a massive speed increase on standard graphics cards.
Yeah, a 4x faster generation, basically.
Right. But what really caught my eye in the stack is that they are trying to push these massive models directly onto everyday mobile phones using something called quantization-aware training. I mean, Apple's newly announced Siri AI is literally integrating Google-powered foundation models natively onto the iPhone. How are they fitting a massive data center brain into a device that sits in my pocket?
That's where that quantization-aware training, or QAT, comes in, going back to our chef analogy.
Love is a chef analogy.
Right, so instead of trying to simplify their recipe after it's been perfected in a massive commercial kitchen, QAT forces the model to learn the recipe using the simplified pinch and handful measurements from the very beginning. By training it to be efficient from day one, it runs natively on edge devices, like your laptop or your phone, and it doesn't even need to talk to a cloud server at all.
The optimization doesn't even stop there, though. Some of the research we have talks about optimizing the actual bedrock of the code itself. PyTorch is now executing what they call fused multi-layer perceptrons, which, from my understanding, is basically combining multiple calculation steps into one so the computer doesn't have to keep moving data back and forth in its memory.
Yeah, to stick with the baking theme, it's like baking the cake in the exact same bowl you mix the batter in.
That is a perfect analogy.
And researchers are pushing it even further. We are seeing breakthroughs where they figure out how to skip the text generation process entirely using hidden state probes.
Wait, skipping the generation. Isn't generating text the entire point of a language model?
You would think so, right? But researchers realize that the actual answer to a prompt often exists in the model's hidden state.
It's internal math.
Yeah, it's internal mathematical representation. The answer is there before it types out a single word. So instead of waiting for the model to translate that math into an English paragraph, you just grab that internal state at the very last token of your prompt, feed it to a tiny classifier, and boom, you get your answer instantly. No text generation required.
Wow. And all this speed is unlocking wild capabilities. I was reading about Anthropic's Claude acting as a literal chemist, predicting NMR spectra, which is how scientists figure out molecular structures. And it's doing it better than traditional specialized software.
It's incredible.
We have astrophysicists using OpenAI's codex to simulate black hole plasma. On the flip side, you have hobbyists building vintage language models from scratch for just $80.
Yeah.
And companies like Recursive are achieving state-of-the-art results with fully automated AI research systems.
It is a total Cambrian explosion of capability, but it brings up a very important question about the nature of this speed.
Right. Let's unpack this for a second, because 1,000 tokens a second is vastly faster than any human eyeball can read.
Not even close.
So if my reading speed is the ultimate bottleneck, why are these frontier labs breaking their backs and spending billions to make text generation this incredibly fast? I mean, it feels like putting a Formula One engine in a golf cart. I can't read fast enough to justify the engine.
Well, if we connect this to the bigger picture, the answer is fundamental. The models aren't generating text for humans to read anymore. They're generating text for other models to read. The bottleneck is no longer the AI itself. The bottleneck is the workflow around it. This blistering speed is the mandatory prerequisite for AI agents. You need models that can talk to each other, debate, check their work, and solve complex multi-step problems in milliseconds.
And that transitions us perfectly into the second major theme from our sources, this massive shift to persistent autonomous agents. Because the models can now think and communicate at lightning speeds, they're no longer just chatbots waiting for you to ask a trivia question. They are digital workers taking over entire workflows. For example, OpenAI is reportedly overhauling ChatGPT to focus entirely on multitasking agents. They just acquired a company called Ona, specifically to support persistent, long-running agents that operate securely in the background for customers.
We're seeing this across the board. Honestly, Microsoft just launched Scout, an always-on agent for their top-tier frontier users that automates routines within the whole Microsoft 365 stack. We are shifting from ask and answer to go and do. Perplexity's new computer agent is reportedly reducing the time spent on complex knowledge work by 87%.
87%. That's just, I saw that, especially in the coding space. Xiaomi's open-source Mimo code just beat Claude code on ultra-long, 200-plus step programming tasks. And what's fascinating is how they did it. They gave the AI an independent subagent whose only job is to sit there and take notes across the sessions, so the main AI doesn't forget what it's doing halfway through the project. And then we have Cursor's BugBot running 3 times faster, alongside their design mode, which lets you just point at a user interface and dictate the changes you want, while the AI writes the code invisibly.
What this signals to the industry is that the competitive moat for these companies is no longer having the smartest, biggest model. The moat is the workflow infrastructure.
Exactly. And that infrastructure is having to rapidly redesign itself to accommodate these invisible workers. In the stack of newsletters we're looking at, there were dozens of new tools mentioned, but a few really stood out. Take a tool like Lakebase. If you have an AI agent working on a database, that agent takes breaks. It pauses to compute, or it waits for an API response.
Right, it's not a constant stream.
So if you keep a traditional massive database running 24/7 for an AI that works in bursts, you will bankrupt your company on cloud fees. Lakebase is a serverless Postgres database that basically scales to 0. The exact millisecond your AI agent goes idle, the database effectively powers down, saving you money.
That is a great example of the physical infrastructure bending to the reality of agents, and we're seeing it in operations too. Celonis has started building dynamic digital twins of businesses. They map out the exact processes of a company so that an AI agent has operational clarity. Because an AI doesn't automatically know how your specific supply chain works unless you map it out for them.
It's getting so complex that ramp-applied AI is literally embedding human engineers into their clients' finance teams just to build these custom agent solutions.
Yep.
And because we're letting these agents loose to write code and change databases, we have to put them in a sandbox. Langsmith just introduced hardware virtualized micro-VM sandboxes so agents can run untrusted code.
Which are absolutely vital, because if an agent is autonomously writing and executing untrusted code, and it makes a catastrophic error, it could wipe out a company's entire server. A micro-virtual machine acts as an isolated, secure bubble where the agent can test its code safely.
But here's where I really want to push back on this whole agentic utopia thing. We are handing off the keys to digital workers for massive tasks. If they're operating invisibly in the background, making hundreds of decisions a minute inside these sandboxes, how do you know they aren't just confidently hallucinating a mistake across 200 steps? If an agent breaks halfway through an automated supply chain order, my whole workflow breaks.
That is the exact nightmare scenario the industry is wrestling with right now. Most agent observability tools currently leave the actual debugging loop to humans.
Right.
If an agent fails, a human engineer has to manually read the logs and figure out why. The next frontier, which researchers are frantically trying to solve, is agent harnesses that repair themselves. Because studies show that 71% of business workflows are completely invisible to corporate leadership. 71%.
Yeah, they happen in emails, in spreadsheets, in private Slack messages. If you unleash AI into that darkness without visibility, you just get automated chaos.
So the focus has to shift from raw model power to strict workflow governance and memory management. But if we have these incredibly fast models running thousands of autonomous loops, talking to each other, managing our databases, that leads us right to the harsh economic reality we teased at the very beginning of this deep dive. Because letting AI think for that long requires an unfathomable amount of server power and electricity.
Unfathomable is truly the right word here. The subsidized illusion we've been living in is fracturing. Those analysts suggesting that frontier labs might be spending over $1,000 in compute for every $100 they make in subscription fees. That is a symptom of heavy users running complex, agentic loops that just burn through resources. The gross margins on a flat-rate $20 subscription are terrible when the product is burning computing power 24/7. And the panic is playing out in the public markets right now. Oracle stock just tumbled 11%. Why? Because they had to announce an additional $20 billion capital raise to cover a staggering $55.7 billion in AI capital expenditures. They're spending unimaginable sums just to build the physical data centers. Our sources note that OpenAI is reportedly weighing a 20-year lease for a data center in Ohio that requires 10 gigawatts of power.
Just to contextualize that for you listening, a standard nuclear reactor outputs roughly 1 gigawatt of power.
Oh my God.
So we're talking about a single data center project requiring the equivalent energy output of 10 nuclear power plants.
That is terrifying scale. And it gets crazier. Google is currently paying SpaceX $920 million every single month just to access 110,000 NVIDIA GPUs as bridge capacity while they build their own centers. The scramble for computing hardware is absolute madness.
Which puts Elon Musk's xAI in a very unique and very lucrative position. Instead of solely competing as a frontier AI lab, xAI is acting almost like a real estate investment trust for compute. They are actually renting their massive supercomputer capacity to their direct rivals, including Anthropic and Google.
Let me make sure I'm following that. They're renting their most valuable asset to the competition.
Yes, because the compute shortage is that severe. The deal is so profitable that analysts estimate xAI could recoup all of its massive capital expenditure in just 18 months. Meanwhile, they are pulling veteran staff from Starlink to run the Grok training teams. It is a massive consolidation of infrastructure power.
But the business world is starting to get fed up with this endless spending. Alex Karp, the CEO of Palantir, just came out and publicly stated that enterprise customers are incredibly unhappy with the frontier labs. He claims these labs are just burning through tokens to signal productivity without delivering real bottom-line business value. And recent data actually backs them up. Despite all these coding agents we talked about, engineering pull request velocity is only increased by 8 to 15%.
Because actually typing out code is just a tiny fraction of a developer's job. Planning, reviewing, coordinating across teams, those are the real bottlenecks, and an AI agent can't easily solve human coordination issues. Yet, despite these efficiency concerns, the corporate maneuvering is accelerating. OpenAI confidentially submitted a draft S1 to the SEC, positioning themselves for an IPO. Perplexity has already planted their flag, planning an IPO in 2028, regardless of what happens to the bigger labs.
So, As a listener trying to make sense of this, it feels like we are in the early Uber phase of AI. Right now, venture capital and tech giants are heavily subsidizing these amazing digital assistants for us, just like they subsidized cheap rides a decade ago. But eventually the bill comes due. Is computing power just becoming a fungible commodity like oil or electricity, where the price will eventually stabilize across the board?
Well, the co-founder of CoreWeave recently made a compelling argument that compute is not entirely fungible yet, and that is where companies are hiding their profit margins. You can't just unplug your software from one GPU cluster and seamlessly plug it into another. The networking speeds, the software layers, the physical location of the data center, all of it matters. The real danger here is for businesses building their entire operations on top of heavily subsidized API costs. When the pricing inevitably corrects to reflect the true astronomical cost of these 10-gigawatt data centers, those complex 200-step agentic loops might suddenly become economically unviable for average tasks.
Which brings us to a critical threshold. When you have technology that is this powerful, this autonomous, and requires the electrical output of a small nation to run, it transcends being just a software product. It becomes a critical piece of national infrastructure. It becomes geopolitical leverage.
Exactly. The sheer scale and cost are inviting massive government intervention and policy shifts.
Our sources highlight some fascinating developments on that front. For instance, there are currently discussions between the U.S. government, specifically the Trump administration, and OpenAI. They are exploring the idea of the government taking a stake in the company via donated equity. The concept being floated is a public wealth fund. The idea is that if AI drastically alters the economy, a sovereign fund ensures citizens benefit from those gains. And obviously, we're just reporting what the documents say here, not taking a stance on the politics, but as a policy mechanism, it shows how seriously Washington is taking this.
And we're seeing an explosion of research around what happens after that economic shift. Economists and researchers are actively studying what remains scarce after AGI. If artificial general intelligence can do most knowledge work, they are trying to figure out new tax and wealth distribution models for this machine-generated wealth. OpenAI even just launched an economic research exchange program specifically to tackle these macroeconomic questions.
At the exact same time, you have the leaders of these labs practically begging for guardrails. Dario Amodei, the CEO of Anthropic, recently called for FAA-style regulation and mandatory testing for exponential AI risks. He wants the government to treat AI with the same strict safety protocols we use for passenger airplanes.
But there is a profound contradiction here.
A massive one. Because at the exact same time Anthropic is publicly calling for FAA-style safety regulations, they are embedding their engineers inside the NSA to customize their Mythos model for offensive cyber operations. And concurrently, they are actively suing the Pentagon over how their models are used in war. You have labs begging for safety regulations while building cyber weapons for intelligence agencies.
The security risks they are navigating are very real, though, which explains the government interest. Take end-day exploits. These are software vulnerabilities that are publicly known but haven't been patched on every single computer network yet. They are becoming incredibly dangerous because AI can instantly reverse engineer a security patch to figure out exactly how to attack the systems that haven't updated yet.
So AI basically takes the window of time an IT guy has to update a server and shrinks it to milliseconds.
Precisely. This is why NVIDIA just had to launch a tool called SkillSpectre. It scans AI agent skills for vulnerabilities before they're even installed. The whole cybersecurity paradigm is shifting. It's no longer just about detecting bad bots. It's about validating the intent of autonomous agents operating on your network.
And honestly, the lack of transparency from the labs themselves isn't helping the trust issue. OpenAI recently introduced lockdown mode to stop prompt injection attacks by disabling live browsing entirely. And Anthropic just faced a massive backlash. Independent researchers discovered that Anthropic was secretly throttling their Claude Fable 5 model. They were quietly rerouting complex requests to lesser, dumber models to effectively sabotage competing researchers who were using Claude to optimize neural architectures. Anthropic had to walk the policy back after a massive public uproar.
It really highlights how entirely closed and opaque these systems really are.
Right. So we have labs pleading with the government to regulate them for safety, while simultaneously embedding their engineers in the NSA to build offensive cyber weapons, and secretly throttling their own users to protect their moats. Plus, on the international stage, Meta is being ordered by the European Union to stop blocking rival AI chatbots on WhatsApp. How on earth do we trust the governance of systems we don't fully understand?
You've isolated the core tension of June 2026. The labs are trapped. I mean, Sam Altman recently stated his 3 goals for OpenAI are building an automated researcher, accelerating the economy, and providing AGI for everyone. But those utopian goals are colliding with the cutthroat reality of national security, investor demands for profit, and the geopolitical race for supremacy. This is why groups like Zenity are pushing so hard for AI agent governance, because getting into these frontier labs now requires what engineers call operating without a map.
What does that mean in practice, though?
It means the complexity is so vast that no single human fully understands the entire system anymore. Look at the recent 1,000 token wood hackathons. Developers are blindly blending models from OpenAI, NVIDIA, OpenBNB, and Quinn together to create diverse agent behaviors. AWS just launched a new Bedrock console making API transitions seamless, allowing developers to hot swap models in milliseconds. When the infrastructure is this fluid and complex, the only way to secure these systems is to demand absolute visibility into how they make decisions. Critical thinking and strict workflow governance aren't just corporate buzzwords anymore. They're the only viable security strategy for national infrastructure.
So to bring it all together for you listening, we have charted a massive, complex journey today. We started by unpacking how blistering hardware-level speeds and optimizations like QAT unlock the era of the autonomous AI agent. We explored how those invisible agents are taking over complex workflows, forcing a total redesign of corporate infrastructure and databases. Then we looked at the precarious, heavily subsidized economics, those 10-gigawatt data centers, keeping these systems running. And finally, we saw how all of this power and astronomical cost has culminated in a high-stakes geopolitical chess match involving the NSA, the SEC, and massive government wealth funds.
It is a landscape that is fundamentally shifting under our feet daily. But I want to leave you with one final thread to pull on as you think about all this. Projections based on the hardware optimizations we discussed in the first segment suggest that by early 2029, Mythos-class open-weight models, meaning models essentially as smart as the massive frontier systems we have today, will be highly optimized and small enough to run entirely locally.
Meaning not in a 10-gigawatt data center.
Exactly, meaning they will run on an everyday device with just 16 gigabytes of RAM.
That is wild.
So consider this. If frontier-level artificial intelligence diffuses to every laptop and smartphone on Earth, functioning entirely offline and for free, how can governments possibly regulate it like the FAA regulates airplanes? Or how can they take equity stakes in something that has become as ubiquitous and uncontainable as mathematics itself?
That is a staggering thought. It brings us right back to that idea of who is driving the car. The steering wheel hasn't just detached from our hands. It's duplicating itself and handing a copy to everyone on Earth, whether we are ready for it or not. Thank you so much for joining us on this deep dive. Keep questioning the infrastructure running invisibly around you, and we will see you next time.
Spoken Tech for your ears.